Let's look at this example. If tangent theta is negative 2 over 5 and the terminal side of theta falls in quadrant 4, we need to determine sine theta. So, since it is given that the terminal side of theta falls in quadrant 4, we can use this table and determine that sine theta is going to be negative, cosine theta is positive, tangent theta is negative. With this information, we will first try to find sine theta prime instead. Theta prime is the reference angle of theta, and sine theta will have the same absolute value as sine theta prime. And since all reference angles are acute angles, they have all 6 trigonometric functions of positive, and their trigonometric functions can be easily determined through a right triangle. Therefore, since tangent theta is negative 2 over 5, tangent theta prime must be positive 2 over 5. Based on this information, we can represent theta prime as an acute angle in a right triangle. We have 2 sides of this right triangle, and we can determine C using the Pythagorean theorem to be square root of 29. Therefore, we can easily determine that sine theta prime is 2 over square root of 29, which is 2 times square root of 29 over 29. And since sine theta has the same absolute value as sine theta prime, all we need to do now is to determine if sine theta is positive or negative. And we actually already did that because theta falls in the 4th quadrant, therefore it will have a sine value that is negative. Therefore, based on this, sine theta equals to negative 2 times square root of 29 over 29. Let's look at this example. If cosine theta is negative 1/3 and tangent theta is smaller than 0, we need to determine cosecant theta. In this problem statement, it is not given directly what quadrant does angle theta fall into, but we can derive that information ourselves. Again, if we look at this summary, and we notice that cosine theta can only be negative in quadrant 2 and 3. But at the same time, we are given that tangent theta is also negative, and we know that tangent theta can only be negative in quadrant 2 and 4. Therefore, only in quadrant 2 can angle theta has both negative cosine value and negative tangent value. Therefore, theta must be in quadrant 2. And in quadrant 2, sine theta is positive. Cosecant theta is the reciprocal of sine theta, therefore it has the same positive sign. So once again, we will try to determine cosecant theta prime first. Theta prime, once again, is the reference angle of theta. And since cosine theta is negative 1/3, cosine theta prime must be positive 1/3. And based on this information, we can represent theta prime as an acute angle in a right triangle with 2 known sides, and we can determine the 3rd side using the Pythagorean theorem to be 2 times the square root of 2. And since cosecant function is the reciprocal function of sine function, based on this, we can determine cosecant theta prime to be 3 square root of 2 over 4. And because theta prime is the reference angle of theta, cosecant theta will have the same absolute value as cosecant theta prime, and we need to determine if cosecant theta is positive or negative. And we already determined that theta falls in quadrant 2. Sine is positive, therefore cosecant theta, being the reciprocal of sine, is also positive. Therefore, the final answer to this problem, cosecant theta is positive 3 square root of 2 over 4.